Hello everyone, Patrick Clayton here with another discussion video. For this one, we're going to be going over a joint variation word problem equation setup. Um, so this is an application problem, and they tell us the simple interest varies jointly as principal and time. Principal is the amount of money you initially invest or borrow. Uh, Time is just going to be the amount of years of your loan or whatever the interest is here. So they're saying if $1,000 for 2 years earned 70% interest, find the amount of interest earned by $5,000 invested for 5 years. So they've given us one example with complete information and one where we're missing a piece they ask us to find. So the first step in these problems is setting up the actual equation we're working here. So they're telling us simple interest varies. Whenever we see something varies, we should set that up as we pick a letter to represent whatever parameter we're dealing with here. Simple interest, I'm just going to use I. And that I, since it varies, is going to equal, I always use K to represent some constant. There's always some constant involved in these problems. We don't necessarily know what it is. So I always start with I equals K, and then we go here, it says it varies jointly. So jointly means we have multiple things that vary directly, which means in the numerator. And then if you ever see the term indirectly, that would be a parameter that would go in the denominator. Basically, we're building a fraction on this side in a case where we have something in the denominator. In this case, we don't. It says jointly by principal, which I'm going to use P to represent, and time, I'm going to use T. So I've got the interest varies jointly by this constant times the principal and the time. So in these problems, since we know K is a constant, there's two ways we can proceed. We could take the three values, plug them in, solve for that K, then rewrite the problem with the K we've solved for in place and plug in the new values. I personally like to solve for K first. I think it makes the problem go a little smoother. So if we take this and solve for that K, basically we're dividing both sides by P and T. And when we do that, we get this equation that K is equal to I over PT. So since K never changes, it's a constant, that means we can take whatever we solved K for and set it equal to itself for different sets of numbers. So basically, the interest in scenario 1 over the principal in scenario 1 times the time in scenario 1 equals that same setup, but for scenario 2. So interest in scenario 2 over the principal for scenario 2 equals and divided by the time in scenario 2. So since these are both equal to K and we know K doesn't change, we know we can set up this relationship. And then we just need to plug in the values they gave us. So the $1,000 is a principal value, so that'll be P1. T1 was given as 2 years, and the interest one was given as 70. So we set up this 70 over 1,000 times 2 just by substituting in those values where they belong. On this side, we're looking for the amount of interest. That's what they want us to find. I'm just going to use X to represent that because that's what we want to know. And then we're dividing that by $5,000 principal and a time of 5 years. So in this case, a lot of students are going to try to multiply this stuff out. I wouldn't multiply anything out yet. It's easier to just solve for X by multiplying both sides by the 5 and the 5,000. And the reason I didn't multiply anything out first is now we have a scenario where we can easily cancel things. when they're in these smaller denominations, it's easier to do. So obviously 1,000 goes into 5,000 five times. 2 and 70, we can take a 2 out of each of those. We're left with a 35. So then our x value is going to equal that 35 times the 25 of those two fives multiplied together. And so if we work that out, I believe that's 875 would be the amount of interest if we invested 5,000 for 5 years. So that would be our solution. So the hardest part about these problems, obviously, is figuring that out that initial setup. If you're more comfortable in the original K equation solving for K and then going back and solving in the other numbers, that's perfectly acceptable. I come from a science background, so I'm typically work these out before plugging in any values, but that's just a hitch of my background. So both ways are correct. And I'll give you guys one to work on the back here, should you choose. So, for the discussion question, it is the force of the wind on a vertical surface varies jointly as the area of the surface and the square of the velocity. If a wind of 40 miles per hour exerts a force of 50 pounds on a surface of 0.5 square feet, how much force will a wind of 80 miles per hour place on a surface of 2 square feet? So if you decide to go with this one, put it in the discussion. Thank you and have a great rest of your day.